Hello, my name is Rob Strickland, and as a pilot, I think it's important for us to understand the forces that act upon an airplane in a turn. But it's also important for us to understand the forces that act upon an airplane at large so that we can understand what occurs in a turn. I've created this mock airplane. Now, this will fly. It may not fly very far, but it will fly because the same forces that act upon this act upon an Airbus A380. We have wings, which allow for lift, and a propulsion factor, which gives us thrust. Now, lift occurs because of something that looks like this. This is a wing. We encounter relative winds, which flow smoothly over the top of the wing, creating an area of low pressure, as opposed to an area of high pressure beneath the wing. This causes lift. This lift is counteracted by weight and gravity. Now that weight, as Murphy says, brings us back down to earth. What goes up must come down. Or on a larger scale, back to the center of gravity, whatever two objects are basically in relation. Now, typically on an Airbus A380 or most other aircraft, we have the catalyst of flight, which is thrust. Now that thrust is created by an engine which converts chemical energy through the propeller into a kinetic energy, which moves the airframe through the air, creating relative winds to encounter the wings. Now that allows for our lift. That thrust, however, is counteracted by drag in two senses. Parasitic, which, as you can hear, the roughness is caused by friction. As this moves through the air, the rougher the skin, the more parasitic drag. And we also have lift-induced drag, or induced drag, which is essentially the movement of an object through a fluid. Just as a ship hull moves through a body of water, it causes a drag. So also an airframe through the media, which is the air. Now that we understand these forces, we can take a look at what occurs in a turn. Typically, the lift force only has to counteract the weight, and they're able to do so easily because of all of this lift. But in a turn, that lift force is converted into two different components. A horizontal component, which does not counteract the weight and gravity, and a vertical component, which does counteract that weight due to gravity. Now, the force of lift, cosine theta or what have you, is equal to that force of gravity. Now we can determine the load factor by the formula FL over FG is equal to 1 over cosine theta, or whatever Greek letter you choose to use. Now that's going to give us a load factor. Let's see that in an example. In a turn with a bank angle of 60 degrees, okay, we're going to find that FL over FG is equal to 1 over cosine of 60. That's going to give us a load factor of 2 gravitational units. You're going to feel some G's going in that turn. But because that load factor basically exists, you're going to have to add back pressure. You're going to have to add back pressure because of the transformation of the lift force into that horizontal component. That horizontal component isn't keeping you up anymore. So without back pressure, you'll turn, but you'll also sink. So what you want to do is add back pressure as you turn, and you'll turn and stay level. Now that's what happens in a turn. Don't forget to add back pressure. Thanks for watching. And just a postscript. The larger the bank angle, the greater the G-force. Past 60 degrees, it skyrockets.